Like many other topics in this course, virtualization in cloud computing could be a course unto itself. In fact, it is a course unto itself for some students. But I'll try to talk a little bit about virtualization in cloud computing in respect to internet or information security. So virtualization is a means of managing and presenting computer resources without regard to physical layout or location. This has become a sort of an emerging technology in IT. It's certainly not a fad. It's here to stay for sure. Most data centers have converted to mostly virtualized data centers. Gone are the days where we have individual hardware devoted to individual services. Instead, we have these shared platforms for computing, which runs within those platforms. We not only virtualize the computing power, but we also virtualize our storage platforms. Our networks are largely virtualized now for that virtualized, for all these different virtualized platforms. So virtualization is for sure a pretty common technique that many organizations are using. Host virtualization is one type of virtualization in which the entire operating system environment is simulated. There are other types of virtualization. You can virtualize applications. You can virtualize storage and networks and things like that. One of the main advantages for virtualization is they're very quick. So you can spin up a virtual machine very quickly. If you work with a virtual environment, or if you work somewhere that has virtual environments, you're probably familiar with the fact that if you try to get access to a new server, it's as simple as clicking a button and you get access to that server. It maybe takes 15 minutes for it to build to some standard build that's already been predefined. Same if you use any of the cloud providers. You go in, set up your account, click a button, it creates the system for you. It's very simple and it's very fast. So that's definitely a major advantage. Resources like RAM and hard drive space are easily expanded and contracted as needed, which is known as elasticity. So again, another big advantage is going to be elasticity. Reduced cost and providing uninterrupted server access to users. And we can reduce those costs and provide uninterrupted service because we can share these resources across many different, all this different hardware. We can afford to have almost every system be highly available because we only need one highly available infrastructure, and we can present virtualized systems within that infrastructure to our users and for our various services. So a lot of really cool things virtualization is doing for us now. As far as security goes, patch compatibility is an advantage. The latest patches can be downloaded and run virtual machine to determine impact on other software. In other words, we can test things before we roll it out to the larger network. You can take a currently running system and you can snapshot it so that you have an exact copy of it that you can use for your testing at that moment in time. And then you can destroy the snapshot when you're done. You can do testing for security controls. You can do sandboxing, which is, for example, you can test potential malware. So if you think something that might be a virus, maybe you have a file that was emailed to you or something like that, and you think it's a virus, you run it in a virtual machine that's in a sandbox. I've done this before with those calls that you get from the companies that are trying to install ransomware on your computer. They call you up and say, "This is Microsoft support. We're here to help you fix your computer," or something like that. In some cases, I have a VM that I'll spin up that's kind of sandboxed, that's gapped from my other networks, and I'll let them in there just to see what they're going to do and to see how the scam works. And it's kind of important to do that because then I can tell users how it works, right? So if I know how these scams are trying to scam me, I can present that to the users, say, "Here's what they did to me. This is how it works. This is what you need to look out for." And I can do that because I can sandbox them into an environment that they can't do any harm. Once they think they've locked up a bunch of files, they don't realize that it's just a fake system off in a corner somewhere that they can't access any other files on the network that are important. So there are also some virtualization risks. The guest operating system that has remained dormant for a period of time. What they're talking about here in your textbook, so you have the host operating system and the guest operating system. The host could either be the hypervisor itself. The hypervisor, by the way, is the software that does virtualization. Or it can run in a host operating system. But within that, you have these virtual machines, which are called guests. So the virtual machine that's running within a system is the guest operating system. And you might shut that guest operating system down for a long time, and then one day you need it and you bring it back up. But in that time, it hasn't done any updates in Windows. So you now have a vulnerable system. So any major attacks that's happened, it's sort of frozen in time, right? So all that stuff that's been upgraded since then, it won't be in effect on that particular machine. So you won't have all of the patches that you need and things like that. So if there still is some virus on the network or some worm or something like that that the machine is vulnerable to, it may get that when you spin up that machine. So again, it's a risk to be aware of. Not all hypervisors have security controls to keep out determined attackers. So there are certain ways attackers can get into systems that are just different with virtualization, and not all hypervisors have the security features that you'll need. Of course, a lot of the commercial virtualization software does have the features, but then you have some of the free ones that maybe don't have the security features that we require. But again, it's one of those things we have to weigh the cost versus the benefit and things like that. Existing security control or security tools do not always adapt well to multiple virtual machines. Virtual machines have to be protected from both outside networks and other virtual machines on the same physical computer. If you recall when we talked about VLANs and all that sort of thing, a lot of that goes away when we do virtualization. It has to be done in the virtual network, which is all within that host operating system. So again, it just adds a little bit of complexity to that security configuration. Now, once we have virtualization and this concept of virtualizing, that's what kind of led to cloud computing, where we basically take our virtual data center, but now it's all in the cloud. So a cloud provider, some major data center operator builds all of this infrastructure out on the internet somewhere that we can use remotely. So you want a Windows 2016 server, you click a button and it builds it for you in their environment, and you have what appears to you to be your own machine that's running in their cloud. You have nearly unlimited computing power, storage, and network. You're only limited by what you're willing to pay for. So cloud computer is pay-per-use computing model. Customers pay for only the resources that they need. Your book says it may revolutionize computer. It's already sort of started. The cloud computing has become a pretty major player to the point where in my work, I'm now migrating whole customers to these cloud providers like Azure and Amazon and Google and so forth. We're moving databases to these platforms, our storage, the actual computers and the servers and the data centers. They're all getting moved into these cloud providers because they maintain the hardware, they maintain the networks on their side, they know what they're doing, they're good at what they do, and all we have to do is maintain our software services, which is what we do for our organizations. So we can kind of concentrate on our core competencies. So a lot of things have changed with going virtual and going into the cloud. It certainly changes, the availability of resources for us and things like that. If we grow, we can very easily grow our data centers by simply, clicking buttons in the cloud platform. So here's some of the characteristics of cloud computing. You have on-demand self-service. The consumer can automatically increase or decrease computing resources without requiring any human interaction from a service provider. So they have these web portals that you can go in and set all these things. Universal client support. Virtually any network device, desktop, laptop, smartphone can access the cloud computing resources. Invisible resource pooling. So they can, and this is where this elasticity comes in, but you can pool your resources. So for example, if you have 18 different services on your network that require databases, but they require different performance levels at different times, you can put them all in one big pool of resources, and the individual applications can kind of grow and shrink to use that pool on demand, depending on when they need it. Immediate elasticity is when you can very quickly increase your computational power, your storage, your RAM, and so forth and so on, to meet the demands at that moment in time. And then metered services, where you only pay for what you use, which is really powerful. If you spin up a virtual machine in the cloud and you're not using it that much, you don't pay that much. You only start to pay when you use it a lot. So once you start or using it enough that you start to meter that service. It's kind of like having electricity in your home. We all have electricity going to our dwelling units, but if you don't use much electricity, you don't pay for much electricity. It's only when you use a lot of it that you pay, that you get the big bill in the mail. And the same thing happens with cloud computing. There are different types of clouds that your book talks about. There's the public cloud, which would be things like Azure, Amazon, and Google and so forth. Rackspace, even to some extent, has public cloud, where you're basically using this cloud provider that's publicly accessible. Anybody can sign up and start using that cloud. A community cloud is open only to specific organizations that have some common concerns or some common use for that cloud. And then private clouds are created and maintained on a private network. So where we're starting to see this is large enterprise is basically building their own cloud in some data center somewhere and maintaining that cloud themselves instead of outsourcing that to somebody like Azure or Google or Amazon. So they build their own cloud. And there are tools available that you can use. Some are open source and some are closed source, commercial products. But there are tools you can use to build a cloud environment very similar to what something like Azure or Amazon or so forth offers. But we can do that all within our own ecosystem, so all within our own network. And then a hybrid is where you're combining both the public and private clouds. Maybe there are some things that we do well in our own private cloud, but there's some things like storage that you just can't do as cheap as Google or as cheap as Amazon or Azure. They all charge pretty much the same amount for storage, and it's unbelievably cheap. And I couldn't go to Best Buy and buy a hard drive and store data as cheaply as I can on that kind of scale that enterprises require, that Google and Azure and so forth can do that. So they have that economy of scale, which you can leverage through these through the cloud. So you might combine different portions of the cloud. Maybe you're going to have your own virtual servers, but you're going to be using storage out in the cloud. Or maybe you're going to have your own virtual environment, but you still want to keep your databases local or something like that. Or you want to keep your databases in the cloud. You can combine this any way you like. And then cloud storage, which is where you have no computational capabilities but only provide remote file storage. So there are three options for the cloud. There's SaaS, PaaS, and infrastructure as a service. So software as a service, platform as a service, and infrastructure as a service. Infrastructure, so when you look at these three, the takeaway here is you are doing the most work with infrastructure as a service and the least amount of work with software as a service. So software as a service is where we basically sign up for some software available on the cloud and we use it in the cloud and we worry about nothing else. So think about your Gmail or whatever email you use that's out in the cloud. The only thing you use is the email provider. You have a way to set the settings in your email and so forth, but you're not setting up SMTP ports. You're not worried about any of that stuff. You're just using their service. That is software as a service. You have to do nothing except use the software. Infrastructure as a service, on the other hand, is where you do everything. The cloud provider provides you with the infrastructure, but you still have to configure it. You still have to install an operating system. In some cases, they give you the operating system. You tell them, I want a Windows server, and they give you a Windows server. But beyond that, you have to do everything else. You can't tell them, give me a Windows server configured as an Exchange email server. You have to configure Exchange on your own. That's your responsibility. And license anything that's third party. You have to do all of that on your own. And then platform as a service is where somebody gives you a platform. A good example of that would be databases. So a lot of the cloud providers, they offer databases in a platform as a service model where you're not worried about the hardware and the operating system or any of that stuff. They simply give you a database that you can configure and access. It's not quite to the level of software as a service because you still have to have a lot of technical capabilities to set it up. But they're basically giving you some platform that you can use as a service. They also do this with web services like Apache and Internet Information Services in the Windows ecosystem. So again, we have software as a service, platform as a service, and infrastructure as a service. And those are the options that we have. So that's it. So I talked about virtualization and cloud computing in this presentation. Prior to this, I talked about both network devices and secure configuration of network devices, some of the best practices that we typically look for in IT security. Obviously, if you take a network security class, you'll talk about a lot of the topics we talked about this week in the previous unit as well in much more detail. But this hopefully gave you a good taste of network security. In the next unit, we also talk about wireless security and mobile device security.